All right, ladies and gentlemen, I'm then going to give to you our last speaker, Mr. Dusty from India. He's not too far from here. I met Mr. Dusty in Brazil for the very first time, and he had a very unique product, but it wasn't available in South Africa. But due to the work network that we had, one call was made, and the next minute, Dusty arranged a shipment to South Africa, and the problem was sorted out. So that's why, the collaboration between countries is so important, because there's countries that may have a product that we don't have. So, sir, the floor is yours. Thank
you. Good afternoon, everybody. Good afternoon. So, to answer Rob's question, why young people don't enter this industry, is because you take 70 people, you put them in a room, then you give them the whole morning and afternoon to get hungry and sleepy, and then you put this poor young guy on the stage, and now he's the only thing standing between them and their free lunch. Okay. My name is Dushyant Sharma. You can call me Dusty. And we have a family business manufacturing cylinder liners. We manufacture cylinder liners for OEMs, but mostly for aftermarket. So I believe that an engine is only as good as its components. And cylinder liner is a component that is not talked about very frequently. So I would like to, in this presentation, go through a very simple concept of what is the purpose of the liner, then what properties it should have to fulfill that purpose, and then how we as manufacturers design the manufacturing process to attain those properties. And I will keep it short. So just to go over the most important functions, the first is it is supposed to wear out. A cylinder liner is a part that protects the more expensive parts like the pistons and the block from getting replaced every time you overhaul an engine. So it is not supposed to wear out very quickly, but just like a bearing, it is supposed to wear out. It's a wear part. It's a service part. The second is sealing. Now, other than the piston rings and the oil, the liner inside surface is the single most important part which will determine the level of sealing and which will prevent combustion gases from escaping into the crankcase and you losing engine power, or from the engine oil escaping into the combustion chamber, and then you have smoke and emissions and so on and so forth. So the inner surface of the liner is very critical. And lastly, the heat sink, which is becoming a more and more important function for the liner, because as others have touched upon this subject also, as emission norms get tighter, pressures go up, temperatures go up in the bid to reduce emissions. Now, liner is the component which has the biggest surface area at the front line of the combustion event. So it has the responsibility of conducting a bulk of that heat away into the cooling media, the coolant or the water, whatever. So heat sink is another very important function of the liner. So keeping these three functions in mind, let us go over a few properties and mechanisms which aid in these functions. Now, in addition to the liner itself, as in all walks of life, lubrication matters. Here I refer to the science of tribology, which studies the relative motion between two surfaces. And a particular property of engine oil is that its viscosity increases exponentially when it is subjected to extremely high pressures, which is what the piston ring does. And the oil film is generated between the rings and the liners and prevents the metal to metal contact. But to keep this film there and not have it drain away, you need a very specific surface texture on the inside of the liner, and a disclaimer here, speaking in front of all the stalwarts of the industry, if there is something which doesn't agree with your experience, please tell me afterwards, quietly, so I can put it in the next presentation. Now, along with the lubrication, once the lubrication is taken care of, now these are some of the properties in a cylinder liner that assist or that enable the liner to perform its function well. From a material standpoint, I will cover two broad aspects, material and geometry. From a material standpoint, the first and the most easily measured is hardness. But because it is most easily measured, it is also most easily misunderstood. I often go to shops in other countries, and where the education has mostly been through experience and does not have a theoretical base, a mechanic will often come up to me and say, your liner is softer, hence it's worse. This competition's liner is harder, hence it's better. And that's a myth. The OEMs, when they design these engines, they put a lot of work and research into calibrating the relative hardnesses of the piston ring and the liner. So just like a liner can be too soft and wear out prematurely, a liner can also be too hard and wear the piston rings out prematurely. So we have to be very careful about selecting which material goes for which engine, and we as manufacturers have had experience and we do that. So I have always been trying to educate mechanics about this hardness aspect, because it's the most easy to test and say this liner is good or bad. Then we come to chemical composition, which refers to the various percentages of carbon, phosphorus, sulfur, and so on elements called as ferroalloys, which we add during the melting phase of manufacturing these liners. Now, just the fact that you don't get any standard material in this world will tell you how important chemical composition is for cylinder liners. You cannot buy a rod or a bar and just machine it and make it into a cylinder liner. You have to cast it yourself. And because it is so important, you have to know the sources from where you are getting these raw materials. Especially because cylinder liners, for purposes of doing it at the right price, you also need to mix a certain amount of scrap, of cast iron scrap. So if you don't select this scrap carefully, there will be a large variation in the ferroalloys present in that scrap from batch to batch, and then you cannot make a consistent material in your foundry. So this is why it is very important to work with manufacturers who in turn choose their sources of raw materials very carefully. Probably the most difficult to measure, because it requires a certain amount of judgment, is the microstructure of the materials. And now there are software which do it for you, optical based softwares. But if you were to give the same microscope slide to 5 different experts, 5 or 10 years ago, they would all give you a slightly different reading of the microstructure, how much type A, how much type B, what is the graphite flake size, so on and so forth. So it requires some judgment, but it is also one of the most important aspects for a cylinder liner material-wise. When we put this carbon, during the melting phase, we put some carbon, which is by far the largest addition percentage-wise, into the cast iron. And then when this cast iron cools down, or when we put this molten metal into a rapidly rotating mold, and this is called centrifugal casting, the cooling rate of this mold, and in turn the cooling rate of the molten metal inside it, transforms this carbon into flakes of graphite, which are the black flakes you can see in the diagram up there. And these flakes of graphite are extremely important. Their distribution, their size, the way they are distributed in the matrix of cast iron is extremely important to determine how the cylinder liner will wear over its life. If you have flakes that are the right size and they are uniformly distributed throughout the cast iron matrix, then you will have a very even wear of the cylinder liner throughout its service life. But if you have hard spots or if you have concentrations of graphite, then obviously it will deteriorate the performance of the liner. So material-wise, we have covered hardness, we have covered chemical composition and microstructure. Now, to talk about the machining aspects, geometry, surface finish. Surface finish, as I mentioned before, of the inside as well as the outside diameter is critical for a good liner. Now, oil consumption, bore roughness, and the rate at which the liner wears out, they are all very tightly related factors, and they all affect engine performance. For about 20 odd years ago, RA was the primary measurement that would tell you something about the surface finish. But today, RA is not enough. Now you have more intricate ways of measuring the surface finish. RPK, RVK, RZ, so on and so forth. They each have their own methodologies to measure it. But for all practical purposes, you just put the liner onto the surface roughness tester and it will give you all the values. The trick is in getting those values during manufacturing. So most of, as you probably know and practice more than us, honing is the process, how you achieve these values. And this process can be aided by certain specialized honing oils, which are available from some leading manufacturers in this world. And that is important. The oil that you use to do your honing process is as important as the machine you have and the honing tools you use. It is all a combined effect of the process that you follow. From a geometrical perspective, because many times reborers usually buy semi-finished liners and they finish them in the shop, so I will focus on semi-finished liners here. The outer diameter geometry is very important for the correct fitment of the liner inside the block. Here again, there is a misconception where the easy way to measure it is to check the ovality of the outer diameter and declare whether the liner is good or not. Ovality is not enough. If you really wanted to test the circularity of the outer diameter of a liner, you would have to put it on a roundness tester, which most of the shops don't have. Because for thin-walled sleeves, the ovality can get disturbed even during transportation. But what this roundness tester does is instead of measuring diameter at just 2 or 3 points, it takes thousands of points across the periphery of the liner, and then it does a root mean squared and all those cool formulas, and it will give you a circularity. And a circularity of less than 30 microns is more than enough for most automotive applications. So if a mechanic comes over and says, look, this is oval, that's not a good enough reason to declare the liner unfit. You have to rely on circularity and not ovality. Now to talk about certain manufacturing processes and practices that we follow to produce good quality liners. It's been our flagship product. Garima Global is the company and Autograce is the brand that we own. And we have been producing liners for practically 3 decades now. And the important manufacturing processes, first of all, during casting, we have a combination of induction melting and centrifugal casting. And this by far is the most advanced process for manufacturing cylinder liners today. So to talk about the induction melting part, you have this induction furnace which creates very high voltage and rapidly reversing electrical currents. These electrical currents cause eddy currents in the material that has been put inside the crucible. These rapidly reversing eddy currents cause heat to be generated within the molten metal, and then that heat causes the metal to melt. Now this also helps, once the metal has been melted, these eddy currents keep the metal in a flux. They don't let the metal sit, which was a problem in the older technologies. So obviously you cannot take a spoon and keep stirring this metal, but these eddy currents don't let the metal sit. So all the ferroalloys that you put in there are uniformly distributed throughout the whole crucible. And that's how you get a nice uniform chemical composition when you pour this metal into the centrifugal molds. Also, since there is no external fuel, like it used to happen in the olden days, like oil or carbon, there is no chance of contamination from that fuel into this molten metal. Another advantage, especially for aftermarket and short production runs, is that you can do separate gradings or separate chemical compositions for every batch. You don't have to run the same chemical composition for a week or a day or even an hour. You can change it for every batch. Along with the induction melting, then we use centrifugal casting. So once this molten metal has been generated, in the olden days, it used to be put into sand molds, and it used to solidify more or less in the shape of a cylinder, and then you'd machine it. Now you have these molds which are rotating on a machine at about 1100 to 1700 RPM, depending on the diameter that you want to cast. And because they are rotating, the centrifugal force causes the heavier metal to be pushed out towards the wall of the mold, and the lighter contaminants like inclusions, dirt, unused inoculant to surface to the inside diameter from where it can be machined away. So this drastically reduces the percentage of inclusions, porosities, because porosities also bubble out to the surface and then they can be machined away. So this drastically reduces all these internal defects that can happen in a cylinder liner. As I said, you need a whole infrastructure of equipment. Probably the whole laboratory would cost you well above $500,000 to actually know whether this cylinder liner is good or bad, to be able to test every aspect of it. And the reality is that most of our shops cannot afford or do not have the technical competence to really test a liner. So these are the basic things that I wanted to share with you, where you can also share this with the mechanics and educate them about what really goes into making a good liner. We can skip the summary. So other than this, this is our major part of the business. But other than this, we also have a trading arm. And what I specifically wanted to talk about with regards to the trading business is that nowadays, more than anywhere in the world, in South Africa, you are aware of the vehicles being manufactured in India are becoming very popular. Mahindra, Tata, Suzuki, many models of Ford EcoSport, Ford Figo, they are being exported from India in very big quantities to South Africa and other markets. The advantage with South Africa is that those manufacturers don't have to change anything because we drive on the same side of the road as you. So it's very easy for them to compete in these markets. So Indian vehicles, you will see more of them in this market. It's a given fact. Indian manufactured vehicles. The brand may be from France, but the vehicle will be manufactured in India because it is very cost effective for them, and the size of the Indian market makes it very cost effective for them to manufacture these vehicles in India and then export them. So what does that mean for us? Spare parts. And we, as Garima Global, have been specializing in developing aftermarket spare parts for Mahindra, for Tata, Suzuki, Renault, Ford, and these models which are being manufactured in India. So this is sometimes a neglected segment of the market, but there is huge potential that you will see will actualize itself in the next decade or so. That's it for me. Thank you very much.
Right, ladies and gentlemen, that just about brings everything to a close. Thank you, Dusty, for your informative presentation. It's good to know that there's more vehicles coming, and obviously there's a market, and there's an open market for spare parts as well. It's been informative, and if I may, on conclusion, just ask for the members to support these suppliers. These are suppliers that we've been working with for many a year, that we've researched, and obviously good quality suppliers. So make the time and make contact with them, and I would say start a relationship with the supplier. That's quite important, and that's what we do at work. We bring the supplier to the member or the consumer in order to obviously do the sale of quality products. Okay. Ladies and gentlemen, that will be the ending of this conference. There's going to be a light lunch served, but just a quick arrangement. We're going to have a work meeting for all the work committee members here today. But that's going to happen right away. So we're going to move out and we're going to get our lunch, but for the work committee, we'll have to come back and we will have to proceed with our work meeting. Unfortunately, it's due to the fact that we've went a little bit over time. But that's not a problem because the information shared today is information captured in our hearts. So from my side, I would like to do the following. Mrs. Dekker, shalom, thank you so much for your presentation. From France, merci beaucoup, thank you so much. From Brazil, obrigado, thank you, sir. From Russia, spasibo, thank you, sir. From South Africa, Afrikaans, baie dankie. And then again in English, thank you for everyone. This is what we do for you because you are the members and everything needs to be plowed back into business. So everything is for you, my friends. Enjoy. Thank you so much.